Welcome back. I'm Dr. Singh, Randhawa, Assistant Professor, PG Department of Chemistry, Khalsa College, Patiala. Welcome back to NMR Nuclear Magnetic Resonance Spectroscopy. Now today we will discuss relaxation process. Basically there are two type of relaxation process. One is spin-spin relaxation, another is spin lattice relaxation. In spin-spin relaxation process, mutual exchange of spins are there. For example, if we have two carbon atoms having hydrogens, so hydrogen, since we are studying NMR of hydrogen atom, proton NMR, so the hydrogen of one carbon may relax with hydrogens of other other carbon, hydrogens of other carbon. Therefore there will be exchange in the energy, and there is no net loss in the energy. So that is an important parameter, because uh, according to spin relaxation, with the help of spin relaxation process, one may get the peak in the NMR spectroscopy. So what about spin lattice relaxation? So in this spin lattice relaxation, there is a lattice energy level, and it will exchange with the spin lattice. That means there is no lengthening, broadening of NMR signal, because if there are three hydrogen atom or three equivalent protons, so we'll discuss equivalent protons, and after dealing with equivalent protons, then it will be easier for you to understand lattice relaxation process. However, the three hydrogen atoms present on the carbon, they will behave as a lattice. So that particular lattice will relax with exchange energy with the other hydrogens of a carbon. So what are equivalent protons? So this is important parameter to have a basic outlook of a NMR. So there are equivalent protons having same environment. For example, a carbon, and this carbon, in case of acetone, these two carbons are having equal environment, but that means they are separated by other carbon with which is bonded with the oxygen. That means the neighborhood of this carbon and neighborhood of this carbon is same. Therefore the environment of these protons, especially we are talking about protons, so environment of these protons is same, magnetically same. Therefore we are only interested in the magnetic environment, so it is magnetically same. Therefore they will have a single peak in NMR spectra. Similarly, the hydrogens of benzene, they are at equivalent in nature, because each hydrogen is surrounded by two carbons having one alternate double bond. So the environment of these hydrogen is same. Therefore same environment means same single peak, so it will show a single peak. So next we will do non-equivalent protons. So this is non-equivalent because the neighborhood of this oxygen hydrogen, the neighborhood of this hydrogen is CH3, and neighborhood of this, therefore in methanol there will be a two peaks. That means the peak of NMR depends upon number of equivalent and non-equivalent protons. Similarly, in case of propanol 2, we can find so this is a CH3. It is a similar type of protons, so they are regarded as A type of protons. They will have a single peak. And this is B type, where B type means it is having neighborhood as CH3 and OH. So this hydrogen is C hydrogen is a different environment, therefore it is non-equivalent proton. There is equivalent proton A and non-equivalent protons B and C. So number of equivalent and non-equivalent protons, they decide how many peaks you will get in NMR. So let us see. So peaks in NMR, and it is given by the n+1 rule. So what is n+1 rule? So according to n+1 rule, so we have to add number of for example, there is a hydrogen in this case. So CH2 is there in A, so there is no hydrogen in B. So we have to add 1. N means number of hydrogen present on the neighborhood. So similarly, C is having a neighborhood C, neighborhood B. So C carbon will have a neighborhood B. So there is, we must add N plus 1. That means N is 0 plus 1. That means the 3 protons will have a 1 signal. So how many for C? So C may have a multiple signal, because multiplet, we call it multiple, multiplet, because there are 3 and 2, 5 hydrogens. 5 hydrogen plus 1 is 6 peaks with some ratio, which will explain how the triangle is important in case of peak. Peak heights are, peak intensities and peak heights are discussed in the next lecture, how these peak heights are divided. So for example, in case of ethanol, so there are 2 examples. It is very important question. So one is pure ethanol. Pure ethanol means OH is there and OH is not participated in hydrogen bonding. In acid added ethanol, that means OH is participated in hydrogen bonding, and the OH bond is prolonged, and it reach out of the scope of the CH2. Therefore it will not exchange any energy with respect to CH2, that is CH2 is the neighbor of OH. However, this long extension is similar for CH2. Therefore CH2 peaks are not divided into further parts. So therefore 1, 2, 3, 4, the CH2 in acid catalyzed is quadrat, and in pure ethanol it is not quadrat, it is a multiplet, because it can exchange energy with the neighborhood, that is OH, that is it is near to the OH. It is capable of exchanging energy, exchanging spin. So next is peaks in NMR. So we are already described how many peaks are there. So there is a type of proton, means similar proton, similar environment. A for CH3 we may have doublet due to 1 proton at B. So if we have no proton at B, so due to 1, so we'll put 0 here, and it will have, so we'll have 1 proton here, so we'll put 1 plus 1, it will equal to 2, so it will be a doublet. So that means 6 hydrogen, 3 plus 3 having same environment, 6 hydrogen will give doublet. On the other hand, the B for CH, so this is CH, H is upwards, so CH we have multiplet due to 6 hydrogen of 1 H of C. So that means we can have, for similarly for C, for OH we have doublet due to 1 H at B. So how excited state we can explain in just in case of excited state of electron. So this is also exchange of, so it may go to this energy state to have this type of, actually this slide was animated, so in this case it is not possible to show the animations. So questions. So is copper 29 be used for NMR? So this is the important question, you have to explain this. NMR of pure ethanol is different from the ethanol which is acid catalyzed, or it is hydrous in nature. Explain why, and what do you understand by resonance in term NMR. So there are few queries, so there are few compounds you have to solve this. So how many peaks these compounds will get. So thank you very much, have a nice day.